Question 9. A sample of 1.55 gram of iron ore is dissolved in an acid solution in which the iron is converted into Fe2 plus. Okay, so let's make a storyline for this question. Okay, so you have an iron ore which has a mass of 1.55 gram is dissolved in acid solution in which the ion is converted into Fe2 plus. So this is your Fe, where ion. So it is converted into Fe2 plus in acid solution. Okay. This solution form is then titrated with K2Cr2O7 potassium dichromate, which oxidizes Fe2 plus to Fe3 plus. Okay. So we titrate this solution with K2Cr2O7, which is your potassium dichromate, which oxidizes Fe2 plus to Fe3 plus, while the Cr2O7 2 minus ions are reduced to Cr3 plus ions. So Cr2O7 2 minus is reduced to Cr3 plus. So 92.95 ml of 0.02 molar potassium dichromate is required for the titration to reach the equivalent point. Okay. So the volume for potassium dichromate is 92.95 ml and the molarity is 0.02 molar. Okay. Alright, so first, write the balance equation for the titration. Okay, so in here, okay, the question does not state whether it is the usual inspection method or the ion electron method. Okay, so look back at all your information. So you are given every compound is in ion form. So you need to write your balance equation according to ion electron method. Okay, because all the reactants and product involved is in ions form. Okay, so let's go on to A. Okay, so the question already states that the oxidation half equation would be for ion, which is Fe2 plus to become Fe3 plus. And for reduction, there would be Cr2O7 2 minus to form Cr3 plus. Okay, so balance the oxidation and reduction half equation. So you've got, so we need to add one electron at the product side of oxidation. Okay, so let's check your reduction. So we've got 2 Cr at here, meanwhile 1 Cr at here, so we need to times by 2. Okay, so this is 7 oxygen, so we need to add 7 water at the product. Okay, so right now we have 7. Okay, 7 times 2, which is 14 hydrogen at this side. So we need to add 14 hydrogen ion. Right? So let's check for the total charge. Okay, so this would be plus 14, sorry, 14 plus negative 2, which would be positive 12, and this would be 2 times 3 plus 0, which would be positive 6. So we need to add 6 electron at the return for reduction half equation. Right? So multiply your oxidation half equation with 6 in order to cancel the electron. Okay, so you got the oxidation new half equation, which is 6Fe2 plus to form 6Fe3 plus 6 electron. Yeah. So for your reduction, just copy down the one you wrote before. Okay. Now cancel off your electron. Okay, and check if there is any similar compounds exist for both reactants and products. Do we have any similar compounds? No. Okay, so your overall equation, okay, you can write it. Okay, it's up to you whether you want to write it in exam or not. Would be the overall equation would be 6Fe2 plus 14H plus Cr2O72 minus to be 6Fe3 plus 2Cr3 positive plus 7H2O. Okay, so let's go back to the equation. Okay. So A, write the balanced ion electromotive equation. Yes, we already done that. So B, calculate the percentage of pure ion in the sample. Okay, let's do B. So B, calculate the percentage of pure. So means you have to find for the percentage purity, which has a formula of pure sample divided by impure sample times 100. Okay. All right, so class. Okay. So look at the question. So this 1 point, this 1.55 gram of iron ore that's too big. Is it your pure or impure sample? Okay. This would be your impure sample. Okay. So okay, this is iron ore. Okay. It is you just extract it from the ground. Okay, so it's still impure, right? So now you need to find the pure sample first. Okay. So let's check. So for this kind of question, which involves ion electrolytic, okay, this information, all information, for example, this K2Cr2O7, okay, is equal to the information of Cr2O7 to minus. Okay, so the compound given, the information for the compound given would be the same as its ions. Okay, so the information for Cr2O7 to minus, okay, that would be, it has the volume of 92.95 ml and the molarity of 0.02 molar. Now the question asks for the percentage of pure ion. Sorry, ion. Okay. So we need to find the mass for pure ion, which is this Fe2 plus. Okay, so what is the mass of pure Fe2 plus? Okay, we need to work with this overall equation. Okay, so can you find the mole for Cr2O7 to minus? Yes. Okay, and then you can compare it to the mole of Fe2 plus. Okay, so first step, okay, in order to find the mass of pure, you need to find the mole and the molar mass of pure Fe2 plus. Okay, so first find mole of Cr2O7 to minus, which would be MV over 1000. Okay, so the molarity is 0.02 times 92.95 ml divided by 1000. So you've got 1.859 times 10 to the power of minus 3 mole of Cr2O7 to minus. Alright, so next, okay, do a ratio. Okay, so from your overall equation, you find out that 1 mole of Cr2O7 to minus is equivalent to 6 mole Fe2 plus. Okay, so 1 mole Cr2O7 to minus is equivalent to 6 mole Fe2 plus. Okay, so 1.859 mole Cr2O7 to minus is equivalent to 1.1154 times 10 to the power of minus 2 mole Fe2 plus. Okay, so we already found out the mole of Fe2 plus. Now we can find the mass for pure ion, which would be 1.1154 times 10 to the power of minus 2 mole times with 55.9 gram per mole. Okay, so your mass of pure Fe would be 0.6235 gram. Okay, so the last step would be to find your percentage purity. Okay, so mass pure divided by impure mass, hence 0.6235 gram divided by 1.55 gram times 100. So your percentage purity is 40.23%. Okay, remember that final answer should be in 2 decimal place. Okay, I'm not gonna tolerate on this. I've already reminded you a lot of times already. Okay. So that's how we're going to answer equation involving ion neutral method and percentage purity. Okay, so let's check where the marks we're gonna get are gonna be given. Okay, so first, when you write your oxidation, when you balance all the oxygen atoms and everything in your half equation, and then when you cancel your electron and then your overall equation, okay, and then next, when you write your formula of percentage purity, and then you find the mole for Cr2O7 to minus, and then you do a comparison, and then you find the mole of Fe2 plus, and then the mass for pure Fe, and lastly, the percentage purity. Okay, so the total mark would be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 marks. Okay, it can be gone higher up to 12 marks for this kind of questions. Last question for chapter 1. Question 10. An analyst titrates an acidified solution containing 0.153 gram of purified sodium oxalate with potassium permanganate solution KMnO4. The purple endpoint, so the endpoint is reached when the chemist has added 41.45 ml of potassium permanganate. Okay, so first of all, write a storyline. Okay, so you've got, okay, the question state already that it is a titration process. So we have a burette with a beaker, sorry, we did a conical flask. So in the burette we have KMnO4 with a volume of 41.45 ml, and in the conical flask we have a 0.53 gram, 0.153 gram of sodium oxalate. Okay. So first question A, write the balance half equation for the oxidation of oxalate ion to carbon dioxide. Okay, so this is kind of like a bonus question. Okay, because the question already gave you the reactant and products to do your ion electron method. Okay, and then the question asks you to write half reaction for the oxidation. Okay, so and then it already stated that from oxalate ion to carbon dioxide. So from oxalate ion to carbon dioxide is oxidation process. Okay, so write oxidation half equation, which would be C2O4 2 minus to form CO2. Sorry, question A. And equation B, okay, I'll write it at below. So question B, write the balanced net ion equation for the reaction between acidified potassium permanganate and sodium oxalate. So balance net ion equation. So whenever you met with the word ion, it means to do ion, electron, method. Okay. So for B, the oxidation process would be C2O4 2 minus to form CO2, and the reduction half equation would be MnO4 minus to form Mn2 plus. Okay, so now I'm gonna balance all of the elements. Okay, so for oxidation we've got 2 CO2 plus 2 electron, and for reduction we have 4 oxygen, so we need to add 4 H2O. Okay, so at the reactant we need to add 8 hydrogen ion and with 5 electron. Now we need to cancel the number of electrons, so we should be multiply the oxidation half equation with 5 and the reduction half equation with 2. So write down again your new half equation. So this would be 5C2O4 2 minus 10CO2 plus 10 electron. And your reduction half equation would be 10 electron plus 16 hydrogen ion plus 2 MnO4 minus to form 2 Mn2 plus 8 H2O. Okay, so cancel your electron all together and check for any similar compounds. No, so we can figure out the overall equation. Okay, which is 5C2O4 minus plus 16H plus 2 MnO4 minus to form 10CO2 plus 2 Mn2 plus 8 H2O. Okay, so for this kind of question, okay, if the question class, okay, for the ion electron method, we usually write it in acidic medium. Okay, so same like question 9. Okay, if the question asks you to find it in basic solution, or in basic medium, okay, the question will state why the balanced net ion equation in basic medium. Okay, only find it in basic medium if the question stated. Okay, if not, you can just leave it in acidic medium. Okay, so we are done with question A and B. So the last question, using the data in the question, calculate the concentration of potassium permanganate. Okay, so what is the molarity for potassium permanganate? So we have mole already. Okay, so we can calculate it by using the formula of molarity. Okay, so molarity of KMnO4 will be mole of solute divided by volume of solution in liter. Okay, so check again. Okay, so the information that you have right now is the mass of sodium oxalate. Okay, so for sodium oxalate, can you identify which reactant would be the same as the chemical formula of sodium oxalate? Okay, yes, that would be this 5C2O4 minus. Okay, So Na2C2O4 is when converted into ions, it will exist in this form. Okay, but it still have the same information, which is it has a mass of 0.153 gram. Okay, so we need to find the mole for MnO4 minus. Okay, so you can find it by comparing it all together. Okay, so in order to find the mole for KMnO4, okay, you need to find the mole for C2O4 minus first. Okay, so let's continue on. Okay, so mole of Na2C2O4 is equivalent to mole of C2O4 minus, which would be 0.153 gram divided by, okay, for the molar mass 134 gram per mole. Okay, so this 134 gram per mole is the molar mass for the solid form. Okay, because you can't find the molar mass of an ion. Okay, so write a short note. Okay, molar mass can only be calculated in form of compound, not ion. Okay, so you've got the mole as 1.141 times 10 to the power of minus 3 mole. Okay, now let's do the ratio. Okay, so from your overall equation, 5 mole C2O4 minus is equivalent to 2 mole MnO4 minus. Okay, so if 5 mole C2O4 minus is 1.141 times 10 to the power of minus 3 mole, okay, then the mole for MnO4 minus would be 4.567 times 10 to the power of minus 4 mole MnO4 minus. Okay, so you have the mole already. So let's find out the molarity. So the molarity of KMnO4 would be 4.567 times 10 to the power of minus 4 mole divided by the volume for KMnO4, 41.45 cm cube. So it needs to be converted into gm cube. Okay, so your final answer would be 0.011 molar. Alright, so last step is to check how many marks will be given for this kind of question. Okay, so first when you balance your all half equations, and then you're canceling the electron, and then your overall equation, and then when you write the formula for molarity and find the mole for sodium oxalate, And when you do the ratio and find the mole for MnO4 minus, and lastly, when you find out the molarity for potassium permanganate. So in total that would be 1, 2, 3, 4, 5, 6, 7. Alright, 7 marks for this question. Okay, so that's all for chapter 1. Okay, so please be prepared for chapter 2.